We will be demonstrating surface tension in a needle. This is the side view of the needle and a long top view. L is multiplied by 2 because there's 2 forces acting on the sides of the needle. So the force due to surface tension is multiplied by 2 because there are 2 interfaces at which the surface tension force is acting upon the needle. And when the force of surface tension is greater than the force of gravity, the needle will float. The force of gravity can be increased mainly by the diameter increasing, which we will be testing today. This is the base formula to see what diameter is needed for the needle to float. We did an example of steel here to find the minimum or the maximum diameter for it to float, and we found that the diameter must be less than 1.6 millimeters in order to float in water.
Here's the steel needle we'll be using today. It has a diameter less than 1.6 millimeters, so it should float in this bowl of water over here. So as you can see, the surface tension of the water is holding up the needle. You can see the water kind of forming a little basket. In the remainder of the video, we will be showing ways to decrease surface tension and the effect that that has. If you look at the graph on the left, you can see that as surface tension increases, the maximum diameter that the cylinder can have and still float also increases. Then you can see as surface tension decreases, the maximum diameter that the cylinder can have and still float decreases. Some ways to increase surface tension are to decrease the temperature of the fluid. Some ways to decrease surface tension are to increase the temperature of the fluid or add a surfactant such as dish soap. If you look at the graph on the right, you can see that as density increases, the maximum diameter that the cylinder can have and still float decreases. So if you were to use something heavier than steel, it would need a diameter much smaller than 1.6 millimeters to float. And then you can see conversely that as density decreases, so if you were to use something lighter than steel, such as aluminum, the cylinder could have a much greater diameter than 1.6 millimeters and still float. As you will see in the following experiment, we left 3 needles on top of the water, and then we will be adding a surfactant, such as dish soap, which will decrease the surface tension of the water, and therefore, even though our steel needles are less than 1.6 millimeters in diameter, they will still sink.
This experiment demonstrates the surface tension again through a different one with pepper flakes. You use pepper flakes in this experiment because they are hydrophobic, which means that they don't want to stick to water, or water's not attracted to them. As the pepper flakes are spread across the top of the surface of the water, they all spread evenly across the water because none of them want to be connected to water molecules. As you introduce the surfactant, in this experiment we used dish soap. Dish soap decreases the surface tension of the water. Because the dish soap was introduced in the center of the bowl, all of the pepper flakes went to the outside because the water molecules want to maintain strong bonds with the hydrogen bonds, so the strongest bonded water molecules expanded to the outside of the bowl as well, carrying the pepper flakes with them.